Hi, my name is David Overbeek, and I work at VMware in the Cloud Management Business Unit in the Technical Marketing Division. And I'm here today to talk to you about this episode or this rendition of School of Ops, which is performance optimization. So let's go ahead and get started because there's quite a few things we want to cover. First thing, what is performance optimization? You're going to hear a whole bunch of different phrases and words and different ways of naming it, and I don't want you to get confused. So we're going to call it performance optimization, continuous performance optimization, workload placement, right sizing, performance right sizing, lots of different phrases. It's changed its names over the years. Don't fret, it all basically falls into the same bucket, which is ensuring that the applications that are running in the environment have access to the resources that they need to be able to perform well. And really, it kind of gets divided up into three major parts. It's deploying the application into the right place in the first place so that it makes sure that the minute it lands, it's got the resources it needs. It's moving applications or even VMs or workloads when they need to get to the resources. So if we've got a lot of contention on a host or a cluster, how do we pick that application up and move it somewhere else where it can get it? But it's also configuring the VM to have the right necessary RAM and CPU requirements, maybe even reservations associated with it so that it can get a handle and get a hold of those resources when it needs them. And that would be kind of under the right sizing piece, if you will. And performance optimization or continuous performance optimization is so important that it's actually an entire pillar for vRealize operations. As you probably have seen in some of the other classes we've taken under School of Ops, there are four major pillars of vRealize operations. And that first pillar is optimizing performance. Again, all about ensuring those applications and the workloads that make those applications have the ability to get to the resources they need at the times that they need it. So let's look at the agenda. I've split this up pretty simply. We're going to talk about what is business and operational intent. We're going to talk about cluster and host-based workload optimization. We're going to just quickly talk about initial workload placement. And then finally, the real easy one, but it's at the end, is right-sizing those workloads. So let's start out by talking about business and operational intent. And this is a really easy concept, but a really important concept to get across to customers and users of vRealize operation. Think about it this way. Wouldn't it be great if you had your infrastructure and your infrastructure would work and act and behave the way you wanted it to? And you could split up your infrastructure into different groups and say, look, this part of the infrastructure, these set of clusters, I want to make sure I'm getting the most possible the best possible performance on my business critical apps. I want to make sure I'm meeting my SLAs, but I also have some compliance needs that I need to follow. So in that part of the infrastructure, that's what I want to set up. I want that to be my business and operational intent. Over here in this other part, maybe it's my test environment. So you know what, I'm going to try to get as much out of this test environment as I can, which means I'm going to cram as much as I can into it, trying to get the biggest VM to host ratio possible, keep my costs as low as possible. That's the purpose, but I'm not really too worried about performance. There's no SLAs in the test environment. So that's really what I want to get out of this particular set of clusters. Then I got another set of clusters that are for something completely different. Maybe it's for standard workloads or older workloads. And there I'm going to set up license enforcement. I've got some Microsoft machines, I've got some Linux machines, maybe got some Oracle machines, whatever it may be. And I want to make sure that they're all running in separate clusters for license enforcement purposes, but I also need to drive the best possible performance of those. Those are all just examples of business and operational intent. Now, wouldn't it be great if you could, within a few buttons and a few clicks, automatically drive that into your environment and even take your hands off the wheel and, in a self-driving sense, let a tool like vRealize Operations kind of manage that all for you. And that's exactly what vRealize Operations does. It automatically allows you to configure your operational and business intent, and then with a click of a button, let it automatically drive that business and operational intent throughout the infrastructure. And it doesn't have to be, like I said, one type. It could be multiple combinations, and you'll see how we set that up. So that's business and operational intent. Now let's take a quick look at how we configure that and why it's so easy to leverage with inside of VROps. So you'll see a complete demo of these screens later, so I'm not going to go into too much detail of where they're coming from because you'll see them a little bit later. But the first thing we do is set operational intent. And setting operational intent really is 2 steps. It's 2 simple questions. What is your target utilization objective is question number 1. Are you trying to balance out this infrastructure? Here's your set of clusters, here's your set of hosts. You want to make them balanced, or do you want to consolidate it all together? Now, what's the difference, right? If it's balanced, obviously I'm going after the best possible performance, right? Because I'm going to spread out the workloads. I'm going to make sure I don't get any kind of weird spikes. And if there is a weird spike, I've got plenty of space available to handle that spike because I've balanced things out. Whereas consolidation is kind of different, right? Consolidation is, you know what, I'm trying to cram as much as possible into this set of clusters or into this data center or whatever it may be. I'm trying to consolidate and cram things together. So you're really going for cost in that case and not performance, right? So you got to pick one, right? Moderate obviously is right in the middle, and moderate will really only deal with moving things around if there's some contention, right? So those are your 3 basic choices. The next is, how much risk do you feel is acceptable in your environment? And it allows you to just say a percentage of headroom, right? And it says, look, how much CPU and how much RAM and how much disk space are you, am I going to set aside in this cluster, for instance, or in this set of clusters before I determine that it's full, right? So let's say I'm moving things around, I'm doing some kind of a balance or maybe even a consolidation setup, and I'm moving workloads around between clusters, moving around. When do I know it's full, right? And this is how you can tell that, right? So in this case, it's 15%. So leave 15% of that cluster space available, draw a line, and never move anything into that environment because I want to leave that just in case there is a spike in the workloads or in some of the applications. That's basically your 2 questions you have to ask. That sets up operational intent. The next one's a little bit more robust in that it's considered business intent and it leverages vSphere tags and categories. So what that gives you the ability to do is to leverage vSphere tags and tag categories. I can simply place a tag on a VM and then a tag on a host or a cluster, and that basically forces vRealize Operations to make sure that that particular VM or set of VMs is always running on those particular hosts or clusters. It's really that easy. And you can do so many things with this, right? You can set up SLA tiers. You can say, hey, look, here's my gold infrastructure, here's my silver infrastructure, here's my bronze infrastructure. When I deploy an application for the first time, all I got to do is tag the VMs with how important it is to my business. If it's gold, it automatically finds its way over to the gold environment. You could do it with licensing policies. Again, like a license enforcement. You could say these hosts and clusters are set up for Windows, these are set up for Oracle, these are set up for Linux. Nobody ever crosses their boundaries. I could also set up a PCI compliant environment and say, look, anything I tag as PCI compliant automatically gets run and put over there. And vRealize Operations will automatically do that for you. Now, once all that's set up, of course, vRealize Operations is watching it, and it's going to determine when one of your data centers is not optimized. Okay, great. I'm going to get a list of data centers across the top of the screen here, as you can see, and it's going to let me know if they're optimized or not optimized. What does that mean if it's not optimized? That means it's not meeting either your operational or business intent. If it's not meeting the operational intent, it means it's not balanced and you asked it to be balanced, or it's not as consolidated as it could be, or it's experiencing contention and things need to move. That's a good example of what is operational intent not being met and therefore not optimized. If it's a business intent problem, it means that you've placed or someone has placed a VM or set of VMs in a place where they're not supposed to be. They're improperly tagged. I've put non-PCI workloads or on a PCI environment, or even worse, I've put PCI workloads on a non-PCI environment, right? Or maybe somebody has placed a whole bunch of, Microsoft VMs on a non-Microsoft licensed environment. Those are all really good examples. And vRealize Operations is going to automatically watch for those problems and let you know, hey, this environment is not optimized. And then, of course, you can click on it and see why is it not optimized. Now, when something is not optimized, what can you do about it? Right? Well, you've got three options, right? You can optimize it now. You can click a little button that just says Optimize Now, and vRealize Operations will bring up a optimization plan, which you'll see in a second, and allow you to make the changes, right? And it'll automatically move things around to make sure everything is optimized. You can schedule it. A lot of customers are saying, look, I don't have time to just move things in the middle of the day. Can I schedule this like during my maintenance hours? Yeah, absolutely. So you can say, hey, run workload optimization, look for anything that's not optimized, make it optimized every Sunday night at 4 a.m. or whatever it may be. You can also automate it. Automating it basically means it will constantly look for optimization problems, and then when it finds one, it will automatically make those changes for you. So if there's suddenly a bunch of contention on one of the clusters and I need to move things around, it will automatically kick in and say, hey, I'm going to go ahead and start moving these workloads to ensure, again, they're optimized, and in this case, can get to the resources that they need. So again, when we run it manually, you'll see a really nice report that is generated by ops. You'll see before and after. Let's see if I get my pen out here. You'll see a before image of the CPU, storage, and memory. And you can see this environment is not optimized because we've got contention here, right? My CPU workload is way into the 95% range. And then it'll let you know, hey, after I move things around, it's going to look a lot better. We're going to go down to 79% workload, right? So it's going to take some of these workloads between production north and move them to the production south environment. In fact, you can see it down here. Here's all the changes it's going to make, right? Here are the VMs it's going to move. And if it needs to move across storage, it'll move across storage data stores as well. So it's going to move across storage data stores. And I'll let you know why it's going to move it, because we're trying to balance out, in this case, our CPU demand. And it's really that easy. Now, if you do it automatically or scheduled, you will get a report at the end to let you know what was changed and what was moved. But that's the gist of workload optimization and understanding how to set up and drive business and operational intent. Okay, so let's move to the next step, which is there are two forms of workload optimization. There is cluster-based, really simple to understand, and host-based, a little more complicated. But we're going to talk about both, and I'm going to give you a real easy example of both of them that you can use to show and explain to other people. So let's start with the easy one, the cluster-based workload optimization. Okay, so cluster-based workload optimization is about moving workloads between clusters. That's it. That's the value it brings, right? So you think about workload optimization runs at the data center or the custom data center level, and a data center or custom a data center or custom data center is made up of a bunch of clusters. DRS is a great tool and does the best job possible, and there's no other tool in the industry like it to move workloads within a cluster, right? So if I have a host that's getting hot, DRS automatically kicks in and takes some of the things off the hot host, moves it to a host that has space available and resources available, drops it there, everybody's happy. DRS does that same thing, but does it between clusters. Right? And again, as it's doing it, it looks at the vCenter tags to make sure that it's placing them on an appropriate cluster. And it's also making sure that when it moves it, it's moving it to a place where it has the resources it needs. So again, think about it. It drives operational intent, right? To ensure that, hey, this whole cluster is busy. DRS can't do anything about this. Something's got to move. vRops kicks in, says, I'm going to start moving things. I'm going to move them over from cluster A to cluster C. There you go, right? But does it while honoring the business intent. So it makes sure it doesn't move anything that's tagged that can't be on cluster C, for instance. Now, this is it. This is the, anything else you get from this first section or the first few sections, this is the big one, right? So let's understand that. So let's talk about an example. A customer is setting up SLA tiering for their business critical applications, trying to drive the best possible performance. They just brought some brand new gold level hardware, fast as it can be, fast storage, yada, 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 the whole thing. And they want to make sure all of their business critical apps are running in these new gold hosts, these new gold clusters. But they also have some silver non-business critical apps, some silver hosts that are still available that they want to leverage, but they don't want to have any of their business critical apps running on it. They want to just have the non-business critical apps there. But there's so much of this brand new hardware, it just doesn't make sense to let it just run for business critical apps. As long as there's space, I want some of these silver workloads, silver applications, to also run in the gold environment, right? So basically, I'm going to set up some clusters that are set up for gold and silver, and then another cluster set up just for silver. So let me show you how that will look. Okay, so I'm going to get out my little pen here. All right, so the first thing we want to do is, what is our operational intent? Well, we know we want to run the best possible performance, so we are definitely going to set up a balanced environment and choose balance for our operational intent. The next thing we're going to do is we're going to leverage vCenter tagging. Okay, so we've got some vCenter tags. Again, these have been created beforehand, and we're going to use something called the SLA tier. So we've set up tags under SLA tier category for gold and silver. And now we're going to do something special with this one. It's called prioritization. Right? I'm going to go ahead and say, look, I want to make sure that we are honoring, from a business intent standpoint, the gold and silver tags. But if there's ever any kind of a question, gold wins out. Basically is what that prioritization means. That means this one's number one, most important, this one's number two. Now, when I go to the actual environment, I'm going to label the cluster, the gold cluster with both gold and silver tags, and cluster 4, which is my silver older hardware, still good, but not super fast. I'm going to label that with silver, right? And now I just go through and I label all my VMs, gold, silver, gold, silver, gold, silver, etc. Okay. Now watch what happens when we turn on workload optimization. As I erase all these, the first thing it's going to do is it's going to say, hey, wait a second, you've got gold VMs here tagged as gold, and this is not a valid place for them to be. They need to move, right? So that's the first thing this is going to do. There they go, right? So it's going to go ahead and send, if we have this set to automatic, it'll do it automatically. If we have it set to manual, it'll alert us and say, hey, you've got two VMs here that are in an improper place. They have to move. Let's move them. Now, let's speed the clock forward. Everything's fine. Everybody's happy. There's no contention. Everything's really well balanced between these two clusters. This is great. But let's roll the clock forward. Now Black Friday comes along, or maybe Christmas in July sale, or whatever it might be. And suddenly there's a lot of contention on some of these applications. They're customer-facing applications, they're sales applications, and cluster 3 is now hitting its limits. It's starting to get really hot on cluster 3, which is, of course, my gold cluster environment, right? And I want to make sure that my business critical gold applications have all the resources they need. And right now, it doesn't look like they do. Again, vRealize operations is going to kick in, and it's going to say, you know what? We need to move some things off of cluster 3 and move them to the silver cluster 4. And it's going to, of course, choose one of the silvers. Right, so it's going to take one of the silver applications, a set of VMs, and whatever it decides, whatever it can determine is the best to move, it's going to move that. And of course, once that gets moved, we're back to no contention here, a nice balanced environment, and it automatically freed up space for my business critical apps so they can finish the sales cycle over Black Friday, whatever it may be. So that kind of explains in a very simple example, and actually this is an example that you'll be able to do, demonstrate using a simple offline demo. So we'll be providing that to you. This is a simplified version of it, and it'll go into a little bit more detail in that particular demo. All right, so let's talk about the next variety of workload optimization, which is host-based. It's a little more complicated, but I think you'll see it's not too bad. So the first thing to understand is, why do we need host-based workload optimization? I thought that's what DRS was for. Well, you'll see in a couple seconds why that's important and why it's still something we need. First off, what we found was a lot of customers have very, very large clusters, tens of hosts, right? And doing uh, business intent at the cluster level was just too much. They really wanted to say, look, I got this huge cluster, it's the Chicago cluster, but these 6 hosts are for this purpose, these 6 hosts are for another purpose, these 6 hosts are for something completely different, and so on and so on. So they wanted to actually split it up into smaller chunks, into host groups, if you will, because that helped them better meet their business intent. The other reason, the other thing they were talking about was, and I could do it with DRS, I guess, but it's kind of a lot to constantly be updating the host groups, the VM groups, the affinity rules, et cetera, et cetera. So they wanted a more automated way to do this. And that's really where vRealize operations host-based workload optimization came about. And it's really about VROps still honoring and doing all of the cross-cluster work, but also working together in coordination with DRS to teach DRS the business intent that the customer has set easily inside of vRealize operations. So let's see how that kind of works. So you still start with vCenter tags from a business intent standpoint. The operational intent is the same. You choose balanced, or you choose, consolidated, or, you just leave it in the middle for moderate. But when you flip over to the business intent, instead of choosing clusters, now there's a new option called hosts, and you're going to enable that there. And what that's going to allow vRealize operations to do is, once you set up your vCenter tags on your VMs and your hosts, vRops is going to look at those tags and say, I'm going to go ahead and create host groups and VM groups in vSphere automatically for you. And then I'm going to go ahead and automatically create VM to host affinity rules based on the tags that I've seen. And thereby, anytime you add a new VM into the environment and it's got its tag on it, it'll automatically update those groups for the VM groups and then automatically roll those into the correct host affinity rules. It's great. So DRS is still responsible for movement inside the cluster, as it always will be, as it always should be. DRS moves things inside the cluster. But now DRS understands the business intent that you're trying to follow, and it actually follows those business intents. vRops is still all about moving things between the clusters, and now it has this new understanding of what a host group is, so it's actually going to balance things between clusters and between the host groups within those clusters, and it's going to honor the business intent between the clusters. So let's take a look at how this gets set up. 2 simple slides just to kind of walk through how this works. So like I said before, choose host-based placement. In this example, we're going to use license enforcement, Linux, Oracle, Microsoft. Those are going to be our tags, so we're going to choose license enforcement as our tag category. We're going to go ahead and include the tags for Linux, Oracle, and Microsoft and place those. Now, once those are placed, vRealize operations starts looking at the environment to say, okay, what do we need to do here? How do I want to best manage this? I need to start creating host groups, VM groups, and VM host affinity rules. Right? And the first thing it's going to do is it's going to say, hey, here's a list of rules that are currently in the environment that are going to conflict with what I'm going to do. Right? So basically it's looking for any VMs or any hosts that already have affinity rules on them that conflict directly with the rule we're trying to create. Because we don't want to create a contentious situation. You can still do DRS affinity rules, they just can't conflict with what you're trying to do in your business intent. So it gives you a list of the rules. In this case, it says, hey, VM to host rule 1. This is one that says VM shouldn't run on these hosts. It conflicts with 2 different tags. If you are okay with this, go ahead and check the box. Understand that VR operations is going to remove that rule and replace it with new ones, right? And then just click agree and hit save, and you're good to go, right? So let's see how this actually is going to work. Again, same use case, because I don't want to confuse anything. 2 clusters with Microsoft hosts, Oracle hosts, Linux hosts. The goal is to keep everybody happy, run the best possible performance we can, keep things balanced within the cluster and between the clusters, but also try to do the best possible job of license enforcement in the environment. So let's take a look at that. Microsoft is blue, Linux is green, Oracle is kind of this pinkish color. The first thing we're going to do is we're going to set up our, where's my pen? There it is. We're going to set up our operational intent balance, right? We want to drive the best possible performance in the environment between and within the clusters. So we're going to go ahead and set that up. The next is we're going to choose host-based placement, and we're going to choose our tag category for license enforcement, which again we created over in vCenter, a while back. And I'm going to choose the tags that I want to enforce. I want to enforce Microsoft, Oracle, and Linux. Then I just need to go up and start tagging my hosts as Linux, Microsoft, etc. And then tag the VMs. Here's a Linux VM, here's an Oracle VM, here's a Microsoft VM, etc. Right? And once that's all done, I hit go on vRealize operations, and it's going to take over and start making these changes for me. So the first thing vRops is going to do is it's going to drive that business intent that we set up with the tags into DRS. It's going to create host groups, VM groups, and affinity rules. And then it's going to let DRS do its job, right? Which is, to move things within the cluster between the hosts. So you can see right away it's going to say, well, look, this shouldn't be there, and this shouldn't be there, and well, geez, these two shouldn't be there. So those are the first things that's going to happen is DRS is going to take over and take responsibility of the business intent within the clusters themselves. Let's see what happens here. Yep, all good. The next thing that's going to happen is vRealize operations is going to kick in and say, okay, I'm responsible for performance and balancing these clusters, and especially balancing the host groups between these clusters, but I'm also responsible for the business intent between these clusters. So it's going to look for tag violations, and it's going to move those. So let's take a look at how that's going to go. This particular host group certainly doesn't look balanced compared to this one, so I'm expecting something to happen here. And I know this poor little Oracle VM can't stay here, so it's going to have to go somewhere else. Hopefully it'll find its way over to there. Let me go ahead and clear this out, and we'll let that run. And there they go. So that's basically host-based workload optimization. Again, the most important thing to remember, the important things to remember is it works together with DRS. DRS still is responsible for it within the cluster. DRS gets its understanding of the business intent from vRealize operations through vRops automatically creating host groups, VM groups, and affinity rules. vRops still is responsible for the operational intent between the clusters, and he also is responsible for the business intent between the clusters, as you saw when we had to move that Oracle VM over. Now, one thing to keep in mind, host-based workload optimization is not currently supported in the hybrid cloud. There are specific types of privileges that are being restricted on purpose because of the hosts that we're running in the hybrid cloud environment. So it's not something that we can leverage to push those kind of DRS changes in automatically. So right now, host-based placement is not available on hybrid clouds like VMware Cloud on AWS, AVS, GCV, etc. Cluster-based placement is already supported and will continue to be supported by that. Okay, we've covered both of the workload optimization processes or varieties, cluster-based and host-based. And we're kind of doing this in a kind of a weird order, but bear with me. Now we're going to talk about putting the workload in the right place to begin with. And that's really where vRealize operations and its integration with vRealize automation come out and shine. Let me show you how that kind of works. Bring out my pen. So one of the interesting things about the integration between vRops and VRA is if you think about what VRA is, it's really telling us from a governance standpoint what can run where, who has the ability to run specific workloads in certain environments. And if you think about what that means, if I've got a project, I'm going to do a deployment, but that's my deployment. This is your deployment. I can deploy here, 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 or I can deploy there, there, or there, and there's all sorts of restrictions. That's really a business intent. Right? So when we're connecting a cluster and saying this particular cluster is going to be used for initial workload placement and it's going to be integrated between vRops and VRA, VRA actually then takes control of the business intent, and the business intent is then grayed out in vRealize operations. Because what we didn't want to do is we didn't want to say, hey, VRA says I could do this with these workloads and it can only be on clusters 1, 2, and 3, but vRops says I can be on 4 and 5 and 6 as well, so who's going to win? So we didn't want a contentious situation, and since customers were already leveraging the richness that is VRA and its governance, we wanted to follow that. So when you're tying these two together and you're managing a cluster and it's being used for initial workload placement, just keep in mind that there's not going to be a business intent setting necessary that VRA will give it to vRops upon deployment. Right? So what that means is you've got here, Scott, our developer, is going to make an initial request for VRA and say, hey, I need to deploy something. Scott already has a reservation set up. He's got, limitations as to what clusters are available to him for this particular project, for this particular deployment, et cetera, et cetera. All of that and the cluster details they're going to go over to vRops. Now, vRops, he knows exactly how busy these clusters are, and he's going to be looking for the best placement for it from a performance standpoint, balance only in this case for initial workloads. And he's going to say, okay, based on all of my choices here of clusters, where is the best cluster for this particular workload to go or this application to go to make sure that when it lands, it doesn't start starving for resources the minute it lands and I've got to move it somewhere else after the fact. So it's going to go ahead and determine what that best placement is, and it's going to go ahead and make a reservation for that, or a capacity reservation for that, and then go ahead and say back to VRA, hey, here is the best place for you to drop this particular workload. VRA then says, great, thank you very much, and it goes ahead and deploys that workload into the cluster that we requested or that we assigned inside of vRops. It's really that easy. Right, so easier than all the others because it's just leveraging, you're just setting up your operational intent and saying, connecting vRops and VRA, and it's pretty much good to go. Okay, so we've covered workload optimization from a host-based and a cluster-based standpoint and initial placement, and we've told you all about business intent and operational intent. So hopefully that all makes sense. Now we're going to talk about the easiest one of all, which is right sizing, right? And some people say, well, why is this in this category? Because it's really, think about the category purpose of workload and, performance optimization is all about, can I ensure that these applications can get to the resources that they need? And if I don't size it correctly the first place, right? If I don't configure it correctly for the right amount of CPU and RAM, it's not going to be able to get to those resources. So that's why this falls into this category. And vRealize Operations has a lot of unique pieces to this, right? So we will let you know, and again, we can use the DC or custom data center viewer at the top here to drive, hey, I want to see how this data center is doing, how this data center is doing, this data center, et cetera. And then it brings up, here's all my oversize, here's my undersize, and then how many of each. This is a pretty bad environment. It's got 80 oversized VMs. It lets you know the total number of CPUs and memory that we're going to be adding, but also the undersized, right? And both of those are performance issues, right? People will say sometimes like, well, undersized I get. If I'm not configured right and I need more, memory or more CPU, I get it. But why is oversized a problem? Oversized is a problem because if you've got a really big VM, 16 vCPUs, it's going to wait until it has an opportunity to get scheduled into the queue of all those other CPUs, and it's going to be fighting for its opportunity to get in there. So having it correctly sized will ensure that it has more opportunities to get put into the queue. If it only needs 4 CPUs, it's going to get into the queue more often and easier. Right, so that's kind of why that works that way. Now let's talk about some of the rules that we've set up inside of vRops to make sure that we are differentiated from any other system that's going to say, hey, just throw some more CPUs at this, take some CPUs away. That's not really how we want to do it. So the recommendation sizes for the VMs and the workloads are based on our capacity engine, right? So it's the AI-driven capacity engine, the trending, the forward-looking components. There's a whole class that we'll be doing in School of Ops on capacity and the capacity engine. So if you need more details on that, please reference that. But we basically have been watching that workload throughout its entire life, and we know what it needs, what its peaks are, what its lows are, how often it needs it. And we've started basically trending out that workload's needs. And if it's growing, maybe it's a more popular application, it's slowly growing and getting more and more use over time, we're paying attention to that. And the recommendation we're giving is good for the next 60 days of this particular workload or VM or application. So we're making sure we're not making changes that we're going to have to just go ahead and put back. So we've watched it, we looked at the trends, we're saying, look, we can make this change, it's a safe change. Now, we're also putting a couple other things on there. We put a couple of caps on the changes, right? So when you're looking at oversized recommendations, we're trying to say, hey, we're going to take away some resources from this VM, right? Here's what we want you to do. We're putting a 50% cap on it. So let me give you the example. So if it's an 8 vCPU virtual machine and it's never ever used more than 10% of the CPU, we could say, hey, this thing could run on one CPU, let's take 7 away. We won't do that right off the bat. We're actually going to do a step down approach. We're recommending that you cut it in half. Hey, let's take, the max we can take away is 50%, so let's take away 4. Now, a week later, it may come by and say, you know what? Still can be taken away a little bit more, right? Let's take 2 more away. Let's take 1 more away after that and get it down to the 1. But instead of showing somebody, hey, let's take this 8 down to 7, that kind of is a little bit of a shock to the system. So we've tried to come up with a better way of doing that. And I'll show you how you can override that as well in the demo here in a couple seconds. Undersized, if I need to add more to it, again, that's capped at 100%. So I can only double what it needs. So if the VM was running at 4 vCPUs and it really needs 6 more, I'm not going to tell you to throw 6 more on there. I'm going to say, let's add 4 more on there and see how it goes. Pretty sure vRealize Operations is going to come back later in about a week and say, hey, let's add some more to that. But, again, shock to the system. Let's not go too far too fast. So let me do a quick demonstration on this one, if I can find my demo. There we are. Okay, so here we are inside of vRealize Operations. I'm in the Optimize Performance panel, and I'm going to go ahead and choose right size. I can choose it from here, or I can choose it from the left panel. And I'm going to say right size, and then you can see across the top is my list of data centers and custom data centers. So, I can do SCDC2, I can do production, I can do, VMC, I can do AVS. Any of these different types of data centers are available in here. In this case, I'm going to go ahead and choose the US data center, and you can see I've got 17 VMs to downsize. It's going to let me know how much vCPU I can reclaim and how much memory I can reclaim, and 1 to upsize. So let's go ahead and open this up and take 30 seconds and show you how this works. So there's my 2 tabs, oversized, obviously those are the 17, and then undersized, there's just this 1. Okay, so it's the same on both sides, so I'm just going to use the undersized as the example. In this case, this particular jump box is recommending that I can reduce its memory by 5 gigabytes. So I have a number of different options available. I can go ahead and resize it right now. It's going to say, hey, let's decrease CPU from 1 to 1, so no change there, and let's decrease the memory from 10 to 5. And I can say, 5 is not a really good number for me. I prefer 6, right? So I can go ahead and do that. It's going to give me a warning to say, hey, if you do this, I may reboot this box and maybe need to restart. Are you sure you're okay with doing this? And you can go ahead and resize the VM, and it'll go off and do that. Take it down from 10 down to 6. We've just reclaimed, right? Same thing on the undersize. I can do that and say, go ahead and add more to it, right? If I need to. Some of the other things I can do here, I can schedule this as an action. This is great because customers say, well, I don't really want to reboot this in the middle of the day, but I can reboot it tonight. So go ahead and set it up as a job, give it a name, give it a description, say when you want it to happen, and then just, hey, give me an email when it's done. Say, I understand that this is going to get rebooted, and go ahead and create that particular job. It'll automatically go ahead and then resize that particular VM. I could even exclude it, which is another thing many customers do, which is, I know these are my business critical apps. I've already asked that, if we could resize these, and my boss and my boss's boss and the application owner have told me no, I may never resize these. So I'm going to go ahead and get them off my list because, honestly, It's kind of annoying to have them always on the list. So there we go. I took 5 of them. I moved to the exclude list. We're down to 12. I can always show those excluded. There's the excluded ones. I can always put them back. I'm going to go ahead and put them back and put them back to include then. I can also, and this is kind of a nice important one, is a lot of times people are like, hey, you know what? I need to print this out. I'm going to go ahead and export this. So I can export that out and then go and have a conversation with the application owners, the cloud admins, etc., whoever I need to be able to talk about how do we want to better utilize these resources and either add more or give some up. And that's basically right sizing in a nutshell, whether it's oversized and recommending we take some away, or undersized and recommending we add more. In this video, I'll be showing you the workload optimization feature of vRealize operations. The specific use case we're going to be talking about is how to set up SLA tiering for your business critical applications. The example I want to use is of a retail customer. This retail customer happens to have a gold cluster that's brand new hardware, super fast, and they want all their business critical apps to run on that particular gold cluster. They also have a silver cluster. It's still good, nice hardware, not as new, not as fast. And their secondary apps or their non-business critical apps are going to need to run there. Now, there's still a lot of room left in the gold cluster, so they still want to be able to utilize those resources, those faster resources. So when possible, they would like those silver non-business critical applications to run on the gold cluster and, get benefits from the fact that it's faster hardware. If anything happens, of course, they want to be able to pull those silver non-business critical apps off the gold cluster and put them back where they belong on that secondary silver tiered cluster. And of course, they want to keep these two clusters balanced as much as possible. The whole point behind keeping things balanced is if you ever end up with a cluster that has a sudden spike in resource need, there's a little bit of gap and a little bit of wiggle room there at the top, so there's not going to be a large sudden burst of resource contention in those clusters. So let's go ahead and see the environment that I've set up visually here. I've got 2 clusters, cluster 3 and cluster 4. Cluster 3 is our gold tier cluster. I'm going to label that one and tag that one as gold and silver. Now, what's important about these tags are actually in vCenter. So these are actually just using vCenter categories and vCenter tags in this case. And in this example, I'm going to be tagging the clusters and tagging the VMs themselves as gold or silver. Cluster 4 is my not as fast silver cluster, and I'm going to go ahead and tag him as silver. And again, I've tagged all the VMs accordingly. Now, of course, right off the bat, you can see, hey, wait a second, there's some gold critical, business critical applications running on the backup, slower silver cluster. I want to go ahead and fix that problem. This is where vRealize operations can come in. DRS is doing things within the cluster, moving VMs around to ensure performance. Within the cluster, vRealize operations has the ability to move workloads across clusters, and in this case, honor these business tags and say, hey, these 2 VMs that are gold need to move over to the gold cluster. So let's go ahead and look at the environment specifically in this case. So I've got cluster 3. You can see it's tagged as silver and gold. I've got cluster 4. You can see it's tagged as silver, and there we go, right down here. You can see I've got at least 1 or 2 business critical apps that are tagged as gold that really aren't supposed to be on this particular cluster and need to be moved up into cluster 3. So let's go ahead and see how vRealize operations can help us balance the environment and drive our business intent of SLA tiering. So I'm going to go to the workload optimization page. And I'm going to click on my business critical app and secondary app custom data center. And we're going to start by setting up our operational intent. So let's go ahead and edit that. Here in the operational intent, I'm going to go ahead and set it to be balanced as we requested. And I'm going to hit save. Now I'm going to go ahead and set up my business intent. And this is where we can set up our SLA tiering. And I'm going to do it based on clusters in this case. So I'm going to choose clusters. And I'm going to set up tier-based business intent. And I'm going to go ahead and pull my SLA tiering. Now remember, this is coming directly from vCenter. These are vCenter tags and vCenter tag categories. So I'm going to choose SLA tiering. And I'm going to go ahead and choose gold and include that tag, and silver and include that tag. Now the other thing we want to do is we want to make sure that we've set up prioritization. Prioritization means that if I ever end up in a situation where gold and silver are running together on the same cluster, which we have in this case, that gold always gets the priority. So I only move the silvers out of the way. So I'm going to go ahead and set that up, make sure gold is set to number 1, silver is set to number 2 as it is, and hit save. Now, right off the bat, you can see that vRealize Operations has found a tag violation. It has noticed those gold VMs running on that silver cluster tagged environment. So I'm going to go ahead and hit Optimize now so I can take care of that problem. You can see a before and after. Everything's pretty well balanced. It's going to move a few things back and forth, but everything's going to basically stay green in this particular optimization plan. Go ahead and hit Next. And you can see right up at the top, it's going to fix these 2 tag violations for my business critical applications. And to make sure things remain in balance, it's going to move a secondary app backwards from cluster 3 back down to the silver tiered cluster to ensure that the CPU demand remains properly balanced. I'm going to go ahead and begin that action. Say OK. I'm going to let time run a little bit and hit refresh. And you can see everything is well optimized in this case. And in fact, if I scroll down, you can see that the environment is very well balanced. I also should probably check on one of my business critical apps. While I'm here, let's go ahead and run our customer database app just to check and make sure that the workloads that I moved over are running properly, and they are. So we've managed to drive and enable our SLA tiering with vRealize Operations business intent. Let's go ahead and roll the clock forward. So now this is the situation we're in. Again, this is a large retail customer, and of course everything's fine until Black Friday comes along. And when Black Friday comes along, you can see there's an increase in resource demand across a number of the different applications. And now cluster 3, which is my gold cluster, is struggling to meet all the resource needs, and we're ending up with contention. What I need vRealize Operations to do, of course, is to balance out the environment again by pulling off at least one of those silver VMs and make space for the gold business critical app VMs. In fact, if you go and look at my customer database application and hit apply, I'm already having a problem reaching it. So the contention is bad enough in that environment that I'm unable to reach, in this case, it looks like the application server. If we jump back into vRealize Operations, you can see, yep, cluster 3, my gold cluster has some pretty serious contention going on, and that's probably why I'm having a hard time with that particular application. Let's go up and let's go ahead and optimize now. In this case, no tag violations, just a balance problem. And you can see the before and after. The workload before for CPU on cluster 3, my gold cluster, is going to go from 98 down to 73, which should fix that problem and put things back into a nice balanced state. And you can see it's going to take a couple of these secondary apps and move them back onto that silver tiered cluster. Let's go ahead and begin that action. Say OK. Again, let time roll forward a little bit and hit refresh, and you can see everything's nice and optimized. In fact, if I come down here, you can see everything's balanced out again. Now, that was certainly scary, and I don't want to have to deal with that again. So one of the things I can do is automate that. If I go ahead and hit automate here, what this is telling vRealize Operations to do is, instead of waiting for me to do this manually, this optimization manually, it will look for opportunities for balance or tag violations based on those business intent tiers and go ahead and take care of it for me. I'm going to go ahead and hit automate on that. Now, one of the things customers always ask me is, wait a second, if you automate it, how will I see what's going on? Well, we've added a new history tab here. This gives you the ability to go backwards and look and see what workload placements have been executed over, in this case, the last 6 hours. So if I come down here and pick this one, this is actually the one that we just ran. You can see cluster 3 is going to go red here. And this is where we run that optimization. And you can see those 2 VMs are moved back over. And again, if I come back here to my customer database, you can see it's responding again. This brings me to the end of this example for setting up SLA tiering for business critical applications using vRealize Operations workload optimization feature. For more information about vRealize Operations workload optimization feature, please visit vRealize.vmware.com. Okay, that's it for me. Thank you very much for listening. I hope you learned a lot about performance optimization, whether it be cluster-based, host-based, initial placement, and right sizing. And I hope you're able to understand business and operational intent and how vRealize operations can help you automate that in your data center. Thank you very much for your time and enjoy the rest of your School of Ops experience.